Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. This video channel is at smarturl.it/pass actuarial exams. Here you can find information about online seminars and study manuals that I offer for exams PFM, IFM, and LTAM. I direct the actuarial program at Illinois State University. You can find it at smarturl.it/actuary. If you would like to refer a tax-deductible, at least to the extent allowed by law, a donation to support our students, please go to smarturl.it/help-ISU-actuary. Here's a problem for today for exam IFM, Investments in Financial Markets. A one-year long forward contract is entered into when the stock price is $100 and the annual risk-free rate of interest is 6% with continuous compounding for all maturities. The stock is expected to pay a dividend in 3 months and again in 9 months. 6 months from now, the price of the stock is 105 and the risk-free rate of interest is still 6% per annum. The value of the long position at this time is $3.99. Calculate the dividend per share, assuming that the dividend is the same at 3 and 9 months. So let's write D for that dividend that we're trying to find. Let F0, actually I should say B, let F0 be the arbitrage-free forward price at the time when the forward contract is entered into at time 0. Then using the forward spot parity, we obtain that F0 must be the accumulated value of the current price minus the accumulated value of the dividends that will be paid at 3 months and 6 months. Now you could also take the current price of a stock and subtract the present value of the dividend. So take the ex-dividend price of the stock and then accumulate all of that to the time at the end of the contract. It would be the same result. The value of the position in half a year from the time the position is entered into is the excess of the value of the forward over the value of an arbitrage-free price forward at the same time. So if we compare it to a forward issued at that time, that would have its price equal to the arbitrage-free price at that time. And the arbitrage-free forward price at time 0.5 years is F0.5, which is the price of a stock, then 105, minus the present value of the dividend remaining. And all of this accumulated over half a year into the future. Or equivalently, 105 accumulated over half a year minus the dividend, which will be accumulated over half the time as the stock, because it will be over only 3 months instead of half a year, and that's why we subtract a D times e to the 0.015. Now, by holding the original forward, the investor buys at F0, while the forward issued at time 0.5 lets him or her purchase at the price F0.5. The value of the original forward position is the difference of these purchase prices in favor of the investor, and that's positive if F0 is less than F0.5, because this means he or she pays less than what the market demands, and negative if F0 is greater than F0.5. But since the actual purchase happens half a year hence, the difference should be discounted, and the value at time 0.5 is that difference discounted over half a year at 6%, or at 6% per annum, so 3% over half a year, and we are told that that's equal to 3.99. Therefore, 3.99 accumulated at 3%, which corresponds to accumulating over half a year, is equal to the difference of f.5 and f0, which we figure out before what they're equal to, so we just plug in those two values. And after we work with them a little bit, this ends up being 105 times e to the 0.03 minus 100 times e to the 0.06 plus d times e to the power 0.045. And now this is a simple equation that we need to solve for d. D is the only unknown, and we solve it, then d is equal to e to the power negative 0.045 times 3.99 times e to the 0.03 minus 105 times e to the 0.03 plus 100 times e to the 0.06. And we calculate all that, and it ends up being equal to approximately 2.005149442, which is answer C. Please remember this is copyrighted material. The problem itself comes from the Casualty Actuarial Society. The solution is mine. Good luck in your studies and good luck on the test.